outside here. So outlier, remember, it could be like very small value or very big value. So whatever value that goes after the minimum or maximum, so which is going to be this tree right here. So those are going to be assumed as being outliers. And how do you calculate outliers? So if you've seen the video, you know that there is a specific formula that enable us to calculate outlier and figure out whether they are actually just a big value or it is actually outliers. Okay, so that will be the idea of what we're going to do today. So I'm going to start with the first example. So this is actually a test problem from semester 1 1819. So it says over here Zatak is a machine manufacturing company. So it's basically a company which produce machine A. So theoretically, so machine A has a capability to absorb energy efficiently. So a study on machine A is conducted to determine the consistency of energy absorption. So on average, the machine will perform consistently. So the result of energy absorption, so in joule, so that will be the unit of machine A is shown in table 1. So this is going to be the energy absorption. So which unit is in joule? Okay, so this is going to be our sample. So first of all, before we start, so let's calculate how many samples do we have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here my sample size n is equal 12. So that's the information, the first information that we know. Okay, so I'm going to, it says over here, so using the data set, so what we're going to do is we are going to draw a box plot. And as I have mentioned to you before, so the first thing that we have to do before we draw a box plot is we need all the 5 number summaries. And what are the 5 number summaries? So it will be all these numbers right here. So minimum value, maximum, quartile 1, quartile 2, and also quartile 3. So let me add a page after this so we can do the calculation. And let me copy this as well. So let's take a screenshot and copy that. Okay, so first of all, so before you start finding the minimum and maximum values, so please forget about that first. So let's first find the quartile. But if you have seen the video that I did before, so when we wanted to find something that is related to position, which is median, quartile, percentile, decile, and so on. So the first thing that you have to do is you have to arrange your data. So first step is arrange your data. So your data should be in terms of ascending order. So ascending means from smallest value until the largest value. So let's have a look at this values that I have. So if you have a look at this very closely, so what happened is that the values are pretty much arranged already, but like, yeah, this 66, 67, but there are a couple of places that we have to change position. So for example, this one, I'm going to change the position. This should have been 1666.2. This is going to be 66.5, and this 2 as well. So 67.2, and this is going to be 67.3. And these 2 values are good together, and this as well. And this is fine. And then I have 73, 74, and 79. So basically, those 4 values have to be interchanged. Other than that, they are already in ascending order. So I have starting from the lowest value until the biggest value. Okay, so the next thing what I'm going to do is, after I have arranged my data, so then only I am going to start with finding the first number summary. And for this case, the first 5 number summary is going to be the quartile 1. I'm not going to start with the minimum maximum first because we haven't verified whether or not we have outlier value. So I'm going to start with finding the quartile first. So I'm going to start with the first quartile, and according to the formula, so the first quartile, the formula is going to be x1 because this is 1. Okay, according to the formula of quartile, so let me put the formula first. So if I wanted to find the quartile of I, so that is going to equal xi multiplied by n, which is sample size. And for quartile, we divide our data by 4. So that is how it goes. Okay, so therefore for this case, because I wanted the first quartile, my I value is equal 1. So therefore I'm going to have x1. And my sample size is going to be given by a value of 12. We calculated that earlier. And divide by 4, and we know that x12 over 4, that is going to equal 3. And if you have seen the notes, if you have seen the video, what happened is that, so x3 is actually the position. So our data is going to be at position number 3. However, so we have to be very careful whenever from your calculation. So you get a whole number, so you cannot stop here. So 3 is a whole number. So basically, what is a whole number? Whole number are counting numbers, numbers that you count using your hands. 1, 2, 3, 4, 5, 6, 7, and so on. Is 1.2 whole number? No. 1.2 is not a whole number. Is 1 over 2 whole number? No, 1 over 2 is not a whole number. So basically, whole number are counting numbers. 1, 2, 3, 4, 10, 11. So those are called as being whole number. So according to the rule, if when you calculate it the formula and you get a whole number, so what you have to do is you have to take x3 plus the number that goes after that, which is going to be x4, and you have to divide by 2. Okay, for this case, this 3 over here is telling us about the position of the number. So in your data set, so x stands for the data set, 3 stands for the position. So what is in position number 3 in our data set? So it's going to be, this is position number 1, position number 2, position number 3. So in the third position is going to be a value of 67.2. Plus in the fourth position is going to be this number, which is 67.3. And all you have to do is divide that by 2. And if you use calculator for this, so you will get that the value of that is going to be 67.25. Is that right? 67.25? So let me calculate this first.
Yes.
Yes, you calculated that? Okay, so it's going to be
Yes.
67.25 according to your friend. Okay, so that is going to be quartile number 1. And then I'm going to proceed to quartile number 2. But remember, quartile number 2 is actually the same as finding the median. And remember that that is like a very easy way of finding median. For example, how many data do I have here? I have 12. So I'm going to do is I'm going to divide that by 2, which is going to be 6 and 6. So this is going to be the first 6 data, 3, 4, 5, 6. And this is going to be the other 6. So what happened is that when I wanted to find the median, I only have to take the middle values of both of them, so which is going to be those 2 values. So basically for this case, my middle value, which is going to be the median, is going to equal 68.4 plus 68.4 divided by 2. And of course, because they are the same value, it's still going to be 68.4. So that is going to be the median value. Okay, so now we already have the first value for our 5-number summary, and this is going to be the second value. So now we need another 3 values. Okay, I'm going to proceed to finding the third quartile. So quartile number 3, and according to the formula, it's going to be x. So now it's going to be 3 multiplied by 12 and divide by 4. And 3 multiplied by 12, that is going to be 36. So 36 divided by 4, so that is going to be 9. So we'll get x9. Is that right? So that's right. So I will get a value of 9. So it's going to be the same idea as previously. So when you calculate using the formula and you get a whole number, so what you're going to do is you're going to take the whole number plus the number that goes right next to it, which is going to be the data at position number 10, and you're going to divide that by 2. So now let's see. So which data is in position number 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be my 10th, and this is going to be the 9th. So when I substitute the value, I will get 70.6 plus 73 divided by 2. So what value will I get from this?
71.8.
71.8. So that is going to be my quartile 3. So it's value of 71.8. So that is the third value that I need. Okay, so now that we have quartile 1, quartile 2, and quartile 3, so what we can do with this is we can now calculate whether or not in our data set, so there are outliers. Okay, because according to the formula, so now I'm going to start calculating outliers. Okay, so outliers. So let me continue right here. Outliers. Okay, first what I'm going to do is I'm going to find the lower bound, and according to the formula, I can calculate lower bound by having quartile 1 minus 1.5 quartile 3 minus quartile of 1. So what do you get for the lower boundary value? Anyone who has calculated?
60.425.
60, 67, you mean?
60. 60.
60?
0.425.
60.525. So anyone got the same value?
425.
4 to 5. 4 to 5.
4 to 5. So it's 60.425. Hold on. This is actually slightly different from what I get earlier. No, it's the same. So, okay, so the lower bound, so the value is going to equal 60.425. Okay, and then I'm going to do the same for the upper bound. So the upper bound, the formula is given by quartile 3 plus 1.5. So quartile 3 minus quartile 1. So what do you get for the upper bound value?
78.625.
Okay, 78.625. So that is going to be the upper bound value. So what happened is that, so a point is going to be considered as outliers if it is smaller than our lower bound value. So lower bound value is equal 60.425. If there is any data set which is less than this value, and it's going to be considered as being outlier, or any value which is greater than our upper bound, so which is 78.625. So that is also going to be considered as being outlier. So now let's see if we have any value. So that is less than 60.425. So from what we have over here, so we do have values that is less than what do you call that? Are you sure you got 60.425? I'm going to have a lot of outliers here if I have my lower bound is 60.45. So can we calculate that again? So can somebody help me calculate this value again? So I'm not sure if it's going to be 60.45, because if it's 60.45, I'm going to have a hell lot of outliers over here. Okay, so what is our value for quarter one? So that is 67.25. So minus 1.5. And then I'm going to have quarter 3. So that is given by 71.8. So minus quarter 1 with 67.25. So that is going to be a value of 60.45. That's actually correct, 60.45. Hold on, let me see what's wrong here. Why do I get 65 before?
Madam.
Yes.
Bukankah lower boundary tu kan yang apa-apa nilai yang ada dalam data tu lebih rendah?
Oh yeah, that's right. Sorry. So
Okay.
I was confused for a bit. Okay, so basically, so it's going to be outlier. That's right for pointing that out. So it's going to be outlier if we have any value. So that is less than 60.425. But when we have a look at our data just now, so there is no value that is less than 60.45, because our highest value, our minimum value is 66.2. So therefore, for this case, so there is no value. So that is less than 60.45. And now we can have a look at their upper bound, for which we wanted to find is there is any x which is greater than 78.625. And when we have a look at our data, so there is one value which is greater than 78, which is going to be this one over here. So it is 79.9. So therefore what happened is that, so we can conclude that 79.9 is going to be an outlier. Okay, so we only have one outlier, so which is a big value that doesn't fit all the data, which is 79.9. So 79.1 is outlier. So it's not going to be included in our data. So what happened is that we are going to remove this. After we have decided on the outlier, so then only we can decide on the minimum and maximum point. So what is going to be the minimum point? So minimum point is going to be the lowest value in our data set. For this case, it's going to be this one, 66.2. And what is going to be the maximum value? So the maximum value now is not including the outlier. So therefore, it's going to be a value of 74.8. So let's put over here. So that our minimum value is going to equal 66.2. And the maximum value, that is going to equal 74.8. Okay, so now that we have all these values, then only we can draw the box plot. So actually, in that tests, they will give you a space that looks like this, but I don't want to draw on this space because you won't be able to see it clearly. But the reason why we have this space is because we wanted you to have an even scale. Remember, your scale has to be correct for us to be able to identify the scale, to be able to identify the distribution of the function. So let me draw that again. That's a super unstraight line. Okay, so the lowest value is going to be a value of 66. The highest value is going to be our outlier, which is going to be about a value of 18. So now I'm going to draw a scale, so which is going to be 66 until 80. So then put some over here. So this is going to be 66. Some over here is going to be 68. This is going to be 70. This is going to be 72, 74, 76. And I have to extend this just a little bit more. And somewhere over here, I'm going to have 78. And this is going to be 80. Okay, so it's not, my skill is not very good right now. But when you do it, so please use your ruler and make sure that the gap between each of this is the same. The reason is that because if it's not the same, then whatever shape that you get out of what you sketch is not going to be exact. It's not going to be a good representation. Right, so now I'm going to start with putting the minimum value. So my minimum value is given by 66.2, so it's just going to be an approximation. So let's say 66.2 is going to be somewhere right there. And then I'm going to put my quartile 2, quartile 1. So quartile 1 is going to be a value of 67.25. So 67 is going to be somewhere over here. So let's say it's going to be right there. And then I also going to have my quartile 2, which is 68.4. This is my 68. So 0.4 is going to be somewhere right there. And the quartile 3 is given by 71.8, which I assume is going to be very close to 72. And then my maximum value is going to be 74.8, so which is going to be close to 75. So and as well, and we also have to put in our outlier, so which is going to be a value of 79.9. So where's my 79.9? So it's going to be very close to the 80. So that goes my outlier. Right, so now remember, so what happened is that this is our quartile 1. So quartile 2, this is our quartile 3. So what I'm going to do is I'm going to draw a straight line that goes through all these points and I'm going to connect them. This is going to become the box. So that is going to be my quartile 2, quartile 3, and quartile 2 and quartile 3. And then the minimum and maximum, all you have to do is connect to the box and you draw a shorter line at the end. So basically that is going to be our box plot. And of course, the outlier is going to remain, whether it's going to be on the lower end or the upper end. Okay, so basically that is how my box plot looks like. So the question asks us to sketch a box plot. So this is going to be our box plot. So then the next question is being asked that we wanted to find the shape of the distribution. So what kind of shape of distribution does this portray? Is it going to be symmetric? What do you call that? Right skew or left skew?
Right.
Exactly. So it's going to be right skew. So remember, what happened is that the median, so this is going to be the peak. Okay, so this is going to be our peak. So when I draw, this is going to be the peak and then it's going to start fluttering towards the right. So therefore, this is going to be the case of right skew. So the shape is going to be right skew. So it says that over here, based on your answer in 2, so based on the shape of this distribution in 2, so what is going to be the best measures of average and variability? Remember what is measures of average? So measures of average are a lot. So we have a mean, so we have median, we have mid-range. Okay, so those are actually measures of average. And what is measures of variability? So measures of variability is going to be variance, standard deviation, what else? IQR, interquartile range. So those are going to be measures of variability. So based on knowing that our data is right skew from sketching the plot, so we are going to decide what is going to be the best measures of average and variability. Right, so I actually explained this in the video before. So if I have a right skew data, so what measures of average is going to be the best? So should I use mean, median, or mid-range when I have right skew data? So which one fits the best?
Interquartile range.
No, for average first.
Mean.
Mean. Median.
No. Okay. The thing is that mean, when you use mean, so you use mean when your data is symmetric. Okay, so when your data looks like this, it's a bell-shaped curve. So the peak is in the middle. Then you use mean as the measures of average.
Mean.
Yeah, but when you have a skew data like what we have over here, we cannot use mean. But in fact, what happened is that for skew data, the average that we use is going to be median. Okay, and what about in terms of the variability?
Median. Interquartile.
That's right, median. That's right.
IQR.
That's right. So in terms of the variability, when I have a skew data, it doesn't matter. It could be right skew, it could be left skew. As long as it's skew, then I'm going to use IQR as the best measures of variability. So remember, so let me put over here. So when you have a symmetric data, so what is going to be the best measure of average? So that will be mean. And how do you measure for the variability? So you could either use standard deviation or variance. So that is going to be the case when you have a symmetric data. But what happens is that when you have a skew data, so when it comes to measures of average, so you are going to use median. And when it comes to measures of variability, you are going to use the interquartile range. So that will be the idea. Okay, and next for the fourth one, so I think this might be the last one for this question. So we're going to give a comment on the distribution of the absorbed energy for machine A. Okay, so the thing about the comment is that if you have a look over here, it's just one mark. Okay, so you can comment on either the median and you can also comment on the interquartile range. So either of them is correct. And another thing is that when it comes to comment, so it could be, it's a subjective thing. So some people see it that way and other people say it the other way. Okay, so it doesn't matter how you comment as long as it actually fits the data. So that is going to be correct. For example, I can say things about the median. So what can I say about the median? Okay, before that, there's something that I forget to tell you earlier on. So when we draw our box plot, so what we actually do is we are dividing our data into 4 groups. Okay, so the first group is going to be before the quarter 1. So the median is going to be in the middle of the group, and this is going to be quarter 3. So basically, 25% of your data is lower than quarter 1. So 25% of your data will be lower than so it's not going to be 25. So it's going to be 50% of your data is going to be lower than quartile 2, and another 25% is going to be here, and another 25% is going to be here as well. So that is why when I talk about the median value, okay, let's say the median value is actually 50. No, that's 50. So let's use a different value than 50. If my median value is equal 8, okay, I can say that. So 50% of the data, so this is my 50% of the data, has a value that is less than 8 because it's down here. Remember, we arrange it according to the lowest value until the highest value. So the highest is here, and this is the lowest. So that is why if our median value is equal 8, we know that 50% of the data that falls into this, it has a value that is lower than 8. So that is how you can actually interpret your box plot. For example, here, so it says, what could you give a comment on this? What I would comment is, for example, if I want to comment on the median, so this is going to be my median. So right here is going to be my median. Okay, so therefore this is going to be 50% of the data. So this is where my 50% of the data is, and 50% of the data is actually has, what is the median value for this case? My median value is 68.4. Okay, so I could say, one of the things that I could say as the comment is that, so 50% of the data is higher or lower than 68.4. Okay, because it's in the middle. So if I take this is 50%, 50% lower than 68.4. So this is going to be another 50%, but this is going to be the 50% that is higher than 68.4. So that is going to be one way that you could comment on your box plot. Or, so instead of like talking about the median, you can also talk about the variability. So according to what we have over here, so which side is more variable? The right hand side or the left hand side? Okay, so this is going to be my left hand side. The left hand side is here. This is the left hand side, and this is the right hand side. So according to the shape of the box plot, so which one is more variable? The right hand side or the left hand side?
Right.
Right side.
Exactly.
So it's much bigger.
That's right. So we can see that. So based
Right.
on the box plot, based on, let's just say based on the plot. So based on the plot, okay, so the data has more variation on the right side. So what are actually the values on the right side? So the right side are actually values so that are higher than 68.4. So that is my upper 50%. Okay, so this one is more variable and it is a value that is greater than 68.4. So that is going to be another way that you can interpret. As I mentioned to you before, so there are so many ways that you can actually comment or interpret a box plot. So as long as what you say is correct, then it should be acceptable. And it is just one mark for this case, so you can see anything. Okay, so that is going to be the case that you have one box plot. So now what happened is that for this second question, so you have more than one. You have two box plot, and we're going to be comparing them. So this second scenario is about a chocolate manufacturing company. So a chocolate manufacturing company conducts a study to investigate which machine will produce the chocolate more efficiently. So we have two machines, machine A and also machine B. So a quality manager collects 12 samples of chocolate from both machines. So from the first machine, we collect 12 samples. From the second machine, also we collect 12 samples. So then this descriptive statistic of the weight of the chocolate is summarized in table 1. So basically, they already give you the 5 number summaries, the minimum, quartile, median, or whatever those values, it's already given. So you don't have to calculate for anything. And they have even sketched the box plot for you. So basically, you don't have to do anything. All you have to do is interpret. But I find that students find interpreting is actually, what do you call that, more complicated than having to calculate. They love calculating more because they could calculate, but when it comes to like having to describe or having to comment the data, so that becomes a major problem for them. So I don't want you to have that problem. So that is why I decide that it's going to be very important for you to be able to comment on this. Okay, first of all, what we're going to do is we're going to determine the shape of the chocolate weight distribution for machine A and machine B. So we're going to determine the shape. So what is going to be the shape of machine A? So when you have a look at this, is it right skew, left skew, symmetric? That's right. So here, remember, this is going to be the peak. When you draw the graph, it's going to be the peak. So the peak is going to be right there. So where does it skew? It skew towards the left. So therefore, for this case, this is going to be a left skew data. All right. And what about B then? What do you see from B? Is it left skew or right skew?
Right skew.
Exactly. It's going to be right skew. So the peak is going to be here. So it's going to taper off towards the right hand side. So therefore, for this case, it's going to be a right skew data. So those are going to be the distributions for data from machine A and B. And then next it says based on figure 1, so comment and compare on the measure of central tendency for both machines. Remember? So the both data over here is skew. So when you wanted to measure central tendency as skew data, so what value should you use? So you should use the median. And if you have a look over here, so this is going to be like a very big percentage. So that's 5 marks for just comparing the measure of central tendency. So how do you tackle this question? So what should you actually tell based on this? So what you can do is first, the first mark will be for stating the value of the median. Okay, for machine A, so just put A. I'm just too lazy to write machine. For A, so the median is, what is the median value? So 68.75. So what does it mean by having a median of 68.75? So meaning that this is 68.75. So this is going to be our 50% of the data. This is going to be another 50% of the data. So one of the ways I can see that 50% of the data, see 50% of the data is higher than 68.75. Or you could also say that. So 50% of the data is lower than 68.75. Okay, both are actually true. And for the case of B, I'm going to say that for B, I'm going to say the same thing. So basically the median is, so what's the median value for data B? So that would have been 72.45. So it will be the same idea. So 50% of the data is higher or lower than 70.45 grams. So this is actually gram unit. Okay, so when you measure the chocolate, so actually 50% of the chocolate is actually higher or lower than 72.45. And then because the question asks you to compare, so you have to compare them. So which one has a greater median? So for this one, obviously, so machine B has a higher median. Machine B has higher median. Okay, so what does that tell you if machine B has higher median? So it's telling you that the weight produced by machine B is higher than machine A. So that is what it's telling you. Okay, so that is going to be in terms of the interpretation. And as I mentioned to you before, like when it comes to interpretation, it is very subjective. As long as you say anything that is correct about the data, so it will be accepted. But when you say 5 marks, there is definitely 5 things that you have to explain. First, state the median value for A and the median value for B, and tell what does it mean by the median value. And then the last mark will be for comparing them. So the fact that for now, so the weight produced by machine B is actually higher than machine B. So that is from the median value. Okay, and then it says here based on table 1 and figure 1, so both from the values and from the sketch, so which machine is more consistent and efficient? So how do we measure consistency and efficiency? So what value would I use for that?
IQR.
That's right. So when we want to measure the data being consistent and efficient, so that is a measure of variation. Okay, so we're actually measuring variation. And for this case, because our data is Q, so how do we measure them? So that will be using the interquartile range. And why is it 5 marks? Because you have to do calculation. First, I'm going to find what is going to be the interquartile range for A, for machine A. And we know the interquartile range, the formula is going to be Q3 minus Q1. So what is the interquartile range for A? So please calculate for me the interquartile range for A.
2.
Just 2, exactly 2.
2.0.
Okay, it's going to be 2 or 2.0. And then for interquartile range for B, what is going to be the value?
2.2.
2.2. Right, so now if I were to compare the value of this interquartile range, I can say that the interquartile range for A is actually less than interquartile range for B. Okay, so that is what we get from the calculation. And I'm going to answer the question. So which one is more consistent and efficient? So from this value, so which one is more consistent and efficient?
Machine A.
Okay, so exactly when it comes to being a variation, remember when it comes to standard deviation, when it comes to variance, so the smaller they are, the better it is. So the same goes for variation as well. So when it comes to the case of variation, so the idea is that the smaller is the better. Put over here, so the smaller the better. So when you have standard deviation or when you have variance or you have interquartile range, the smaller they are, so it means that it is more consistent and more efficient. So therefore, for this case, machine A, which has smaller interquartile range, is more consistent and efficient. Okay, so therefore by just answering this, so you will get 5 marks. So if you just simply tell me machine A is more consistent and efficient, I will just give you 1 mark. So therefore, when you come across question like this, so you have to calculate the IQR of A and IQR of B. So that is what going to give you another remaining 4 marks. It's a simple calculation, but trust me, student usually would skip this. They would simply state that. So machine A is more consistent and efficient. You have to give me a reason. Why do you say that? And how could I give you 5 marks with just the statement by itself with no proof, right? So be careful when you answer the question. Have a look at the marks allocation. How many marks is given? Okay, so this is going to be in terms of this as well, but I think I want to skip this. You know what? What I'm going to do is I will send this file to you later, and I'm going to give you the solution for this as well. But I'm going to skip discussing question number 3 because I want to discuss a little bit on chapter 2. So I have a question over here in chapter 2. I noticed that in the video, so the video link that I gave you, so those are actually recorded by other lecturers, and I noticed that she has not really shown you the book. So I want to show you the statistical table book. So this is what you're going to use for chapter 2. So throughout chapter 2 until chapter 6, you always have to use the statistical table in order to find values. So that is why if you still don't have this, so please buy this. I don't know, like you can buy this or like any means that you can do as long as you have this book, because there are many values that you have to find by using this book, and that include formulas as well. Okay, so chapter 2, what happened is that we're going to be talking about confidence interval. So this is going to be on page number 5. So all the formulas that you're going to use for confidence interval is going to be on page number 5 and also page number 6. So the first topic will be on confidence interval for mu. So there are a bunch of formulas over here. How do you differentiate them from what's written over here? So when this question asks you confidence interval for mean, so this is going to be the confidence interval for mean. So we have 3 formulas altogether. So you have to decide which formula that you have to use. So based on conditions that is given in your statement. Based on the scenario, you're going to decide. So whether you're going to use formula number 1, formula number 2, or formula number 3. And I noticed that the major problem that students have is that from the statement given, so which formula they actually have to use. So I'll explain this to you in a bit. Okay, and then right after the confidence interval for mean, so we also have this, so which is confidence interval for difference between mean. So you have 2 means, so you're going to find what happens when you have a difference between them. So this is going to be for difference between means. So this is going to be the case for independent sample. So independent sample. So this is for topic of this week. And then underneath over here, so for this one, you have 5 formulas altogether. So 1, 2, 3, 4, and 5. Okay, and then you also have underneath over here, so this is a formula for mu d. So what does mu d stands for? So that is called as mean difference. Okay, this is going to be concerning the case that you have dependent sample. So you have 3 formulas as well. So 1, 2, and 3. So you have to pick, so for according to the scenario given, so which formula do you have to use? And then this is going to be the confidence interval for the case of proportion. And this will be difference between proportion. And then the last one will be in terms of confidence interval for variance and ratio of 2 variances. So I'm not going to explain to you in detail each of them because you haven't seen them. But for now, according to last week's material, you should have already seen this, the confidence interval for mean. Okay, so when you wanted to find a confidence interval, so you're going to use one of this formula, and I wanted to highlight to you as well. So how do you find this value? So Z and also T. Okay, so let's make up some values. So I'm going to, no, let's not do that. So I'm going to add a blank page. Okay, for example, so if you want to find what is going to be Z 0.05, so in your calculation, you need to find Z 0.05. So how do you find Z 0.05? So this number, so it's going to be on page number, what page is that? It's going to be this one. Okay, so it's going to be this one here. So this will be on page number 36. So let me put over here so you can refer to that later. So this is going to be on page 36. Okay, as I mentioned to you just now, so what if we wanted to find the value of Z 0.05? So if you have a look at the table right here, there are actually two columns. So the first column is for alpha value. So this is going to be the value of the alpha. So according to what we have over here, so whatever that goes underneath, so this is going to be the alpha value. And what goes on the next column right next to it, so that is going to be the value of Z alpha, the value that we are looking for. Okay, and we have how many rows over here? So we have, this is 1, 2, 3, 4, and 5. Okay, so because we have so many values. So now, for example, let's say if I want to find what is going to be Z 0.05, first I'm going to identify the fact that alpha is equal to 0.05, and I'm going to go down the first column and find 0.05. So it's not here, so here it stopped until 0.023, and I'm going to go to the next column, and I find that here this is my 0.05. So the value that I wanted is not that value, but the value right next to it, so which is going to be this one. So therefore, for this case, so if the question asks you what is Z 0.05, so that is going to equal 1.6449. Okay, or if I were to give you another example, so let's say now we wanted to find what is going to be Z 0.1. So it's going to be the same idea. First of all, I'm going to find the position of 0.1 for the case of alpha. So where is 0.1? For my case, 0.1 is
2.3263.
So what value is that?
2.3263. This is 01 on the left.
1.2816.
Yeah, no, I get this value. So this is going to be that value. Okay.
1.28.
Because I wanted 0.1. So 0.1, the value is 1.2816. So here I'm going to have 1.2816. So that is going to be that 0.1. But you have to be very careful. So 0.1, or is it 0.01? So please have a look at them very carefully. I know that there are a bunch of numbers right here. It could be blinding. So therefore, when you go down and find the values, so be very careful. So that is going to be for the case of Z. But if you have a look in the formula over here, so there are also certain formulas that instead of using Z, you're going to use the T distribution. So how do you find this T distribution? So it's going to be on the page that come right next to the Z distribution. So this is going to be on page number 37. So here, so this is what we wanted. Okay, so previously when we have Z, we only have one parameter, so Z alpha. So this alpha over here is called as being a parameter. But when you have T distribution, you have two parameters. So for example, so I want to find what is going to be T 0.053. So I'm going to have two parameters. So the first parameter is going to be for alpha. So the second parameter stands for nu. So that is why if you have a look over here, so we have two columns. So the first column, so which is going to be on the side. So let's have a look at the one at the top first. So the one on the top, so this is going to be for alpha value. So here, the one at the top. Okay, so this whole thing over here is going to be a value of alpha. And for this case, I wanted to find what is going to be for the case of alpha is 0.05. So where's the 0.05? So it's going to be right there. So that is going to be the column that I will be referring to. And then I have to concern the case of my nu, which is equal 3. And I have to refer to the row on this side. So I have to find where is my nu equal 3. And for this case, my nu equal 3 is going to be right here. And all you have to do is find the intersection between them both. So which for this case is going to be right here. So therefore, when I wanted to find what is going to be T 0.053, the value is going to equal 2.3534. Okay, so remember you have to look first at the top and then second at the side. So let me show you another example. So let's say I want T 0.0251. So where's 0.025? So at the top is going to be right here. And please do not mistakenly have a look at 0.0025. So now there is only 0 after this decimal. And that one is going to be 1. So 1 is going to be on this side. So therefore, the value I'm going to find is going to be right at the top over here. So it's going to be a value of 12.7062. So that is going to be how you are going to use the statistical table. So the Z distribution, that is going to be on page 36. The T distribution, so that will be on the next page, which is page 37. And later we'll be using this distribution as well for the next preceding cases. Okay, so let's have a look at the exercise that I put over here, that concern for this case. So this is going to be the example. So it says over here, but before this, let me explain to you about the formula first, in case like sometimes students get confused about this as well. Okay, so for the case of confidence interval for population mean, so now we're talking about mean. So there are 3 formulas. Let me call this as formula number 1. This is formula number 2. This is going to be formula number 3. So before you start, like figuring out which formula do you have to use. So first question that you have to ask yourself is the sigma given? Can anyone tell me what is sigma? What is sigma?
Is it the variance?
Okay, sigma, if I put sigma squared, then it becomes the variance. Variance of what?
Standard deviation.
Yeah, standard deviation for population.
Exactly. So it's going to be variance or standard deviation for population. If I use sigma, so that will be standard deviation. If I use sigma square, then it will be the variance. Okay. So this is going to be the first question that you have to ask yourself. So in this whole statement, is the value of the sigma given? So it doesn't matter. So it could be a value of sigma, or it could also a value of sigma square. So if either one of them is given, so what you're going to do is you are going to use formula number 1. So this is going to be the formula that you're going to use if sigma is given. However, what happens if sigma is not given? Then this is going to be the case. Then you will either use formula number 2 or formula number 3. So how do you decide whether to use formula number 2 or 3? So the second step you have to ask yourself is the sample small or big? Small or big? Okay. So when you have n is greater or equal to 30 and above, so this is going to be considered as being a big sample. If your n is less than 30, for example, 29, 28, 15, 10, so this is going to be considered as being a small sample. So if you have a big sample, so you use formula number 2. If you have a small sample, you're going to use formula number 3. So that will be the rule. Okay, and what is the difference? Okay, there is only a slight difference between all these formulas. For the case of formula number 1, you use sigma on top, but for the case of number 2 and number 3, you use S in the formula. So that will be the difference between that. Okay, and what is the difference between number 2 and number 3? So that will be concerning the distribution that you use. When you have a big sample size, you're going to use the Z distribution, and when you have a small sample size, you're going to use the T distribution. And as I mentioned to you just now, like the major mistake that student did in this subtopic would be using the wrong formula. When you use the wrong formula, automatically your whole calculation is going to be wrong. I would not be able to award you with any marks, so be careful with that. So let's check out this question from the exercise again. So here it says that a study was carried out to investigate atmospheric ammonia due to automobile traffic in Kuantan, Pahang. So the ammonia concentration were measured for 7 days at an urban site in Kuantan. So the data are collected and recorded as in table 3. Okay, so I have my ammonia concentration recorded for 7 days from Monday until Sunday. So the first question, it says identify the variable involved. So remember I told you what is the variable? So the variable is going to be what data do we collect? So what data are we collecting here? What is our variable? What data are we collecting?
Automobile traffic.
The concentration of ammonia.
Exactly. So usually the variable is going to be the header of your table. So what are we collecting? So we are collecting the ammonia concentration. So that is why for this case, when it says identify the variable, so the variable is going to be the ammonia concentration. Okay, and then the question asks us to determine its level of measurement. Remember, we have 4 levels of measurement: ordinal, nominal, ratio, and interval. But for this case, what happened is that our our data is actually a quantitative data, a constant number. It could either be ratio or interval. So which one is that for this case? Is this a ratio data or is it an interval type of data?
Ratio data.
Ratio data.
That's right. So this is going to be a ratio data. Remember, what is a ratio data? So ratio data means that when it's zero, it is none. So that is what it means by having a ratio data. So meaning that when I say that the ammonia concentration is zero, mean that the concentration is zero. Nothing is there. Okay. So that is why for this case, our ammonia concentration is going to be ratio. And the second question, it says construct a 90% confidence interval for the population mean of ammonia concentration. Okay, before we start, the first thing is you have to be able to identify what formula that you are going to use. Remember the first question that I told you before? So the first question that you have to ask yourself, is sigma given? Is there any statement in there that give you the value of sigma?
No.
No. So nothing over here actually states the value of sigma. So therefore, formula number one is going to be ruled out. You're not going to use formula number one. And number two, we are going to have a look at the sample size. What is my n value for this case? What is my sample size?
7.
N is equal 7. I have 7 data over here. 1, 2, 3, 4, 5, 6, 7. So I have 7 as my sample size. Is it a big data or small data? Small sample size or big sample size?
Small data.
Exactly. So this is going to be considered as a small data. So that is why we are going to use formula number 3. And even in your formula book, so where's the formula? So it's going to be here. So it is actually rearranged that way. So this is going to be formula number 1 where sigma is given. So this is going to be formula number 2 for which we have a big sample size, and formula number 3 for which we have a small sample size. And for this case, what happened is that we are going to use the third formula. So let me copy this formula, but let's clean that up a little. So I'm going to take this formula. So this is what we're going to use. Take a screenshot of that, copy, and then I'm going to paste it here because we're going to use this. Okay. Why does it become like that? Let me paste that again. Okay, so basically this is going to be the formula that we're going to use. So in order to use this formula, so we need to have all these values. So the first value that we need is going to be the x bar. So in the formula, we have x bar. So first find the value of x bar. So x bar is the mean. How do we find the value of the mean? So what should you do?
Plus all and divide by 7.
Okay. So yeah, of course, when you have a mean, you have add up all the data and divide by 7. Okay. However, remember, you don't only need to find the value of x bar. You also later need to find the value of S, which is going to be the standard deviation. And please do not use formula to find the standard deviation. So this is where you are going to use your calculator. So put all these values into your calculator, 1, 2, 3, 4, 5, 6, 7, and find what is going to be the value of x bar and the S. Can someone tell me what is the value of x bar if you have already calculated that? If you haven't, then pick up your calculator.
3.4571.
3.45?
71.
71. Okay, so that is going to be the x bar. And what about the S value then?
0.4158.
4.58?
4158.
4158, yeah, that's right. Okay, so therefore, these are going to be my value of x bar and S. Okay, and I already know what is going to be the value of n, so we already know that n is going to be 7 because we have 7 sample. And then we also need to find this t distribution. So before I find this t distribution, first of all, so we need to find what is going to be the value of alpha. And I'm pretty sure if you have seen the video that you have known how to find the value of alpha. For this case, our confidence level is going to be 90%. So 1 minus alpha is equal 90%, which is 0.9. So my alpha value is going to be 1 minus 0.9, so which is going to be 0.1. So therefore, when I wanted to find what is going to be T alpha over 2, so basically I need T. So alpha is going to be 0.1, so it's going to be 0.1 over 2. And then I need to find what is going to be the value of mu. And according to the formula over here, so what is going to be the value of mu? It's already written down here that mu is equal n minus 1. So this is actually not V, this is called as nu, nu. Okay, and the formula for nu is n minus 1. So what is going to be the nu value for this case? So for this case, I'm going to have 7 minus 1 because my n is equal 7. So 7 minus 1, that is going to equal 6. So basically, what t value do I need to find? So 0.1 divided by 2, that is going to be 0.05. So 6, now this is going to be the value that I need to find in the table. So 0.056. So let's get back to the t distribution. So it's going to be here. So 0.05 is going to be here. And I'm going to find the value when it's going to equal 6. So basically, the value is going to equal 1.9432. Is that right?
Yes.
Okay. I'm going to have 1.9432. So now that I have all the values, what I'm going to do is I'm going to substitute into the formula. So what is going to be my x bar? So that is going to equal 3.4571. And if you notice, the formula, it is exactly the same. That the only difference between them is one is going to be a plus here, one is going to be a minus. So that is why what we can do is, so usually I'm too lazy to write both of them. So I simply going to write plus and also minus. So one operation is going to be minus, it's going to be on the left. One operation is going to be plus. And then I'm going to start substituting t. For this case, it's going to be 1.9432. So multiply by s, which is 0.4158, and divide by square root of n, which is going to equal 7 for this case. So let me put a larger bracket for this. Okay, now use your calculator. So tell me what is going to be the value when you do the minus operation. So what's the value for this?
Um, 3.1517.
3.1517.
1517.
And what happened when you plus?
3.762.
3.762. So it's exactly like 3 decimal places.
3.7625.
Yeah. So remember, when you do your calculation, so make sure it's 4 decimal places, unless it's 0 at the back. So it's going to be 3.7625 for this case. And when you have confidence interval, please do not forget about the unit. What is the unit for this case? Our unit is going to be, what unit is it, by the way? It's going to be mu gram over m cube. So that is going to be the unit. So simply put that right next to it. Okay, so this is going to be the calculation. And this is actually going to give you 6 marks. So this is not 2 marks, this is actually 6 marks. Okay, so just by writing this, you will get marks already. And putting the formula together, so that is already marked. And you will get 1 mark each recorded for each of the lower bound and also the upper bound. And please, again, so when you put confidence interval, do not forget to write down the unit. Unless no unit is given in the question, then that's a different case. Okay, and as I mentioned to you before, so the thing that I'm concerned the most about, students, is like finding the right formula for it. So let's have a look at a couple of scenarios right here. So in the video, I'm pretty sure that the Shahida has discussed some, but I wanted to clarify with you. Like, I have to make sure that you really understand so which formula that you have to use for each of these cases right here. So let me pick random one. So let's pick number 2 over here. So for scenario number 2, I'm not going to do the calculation. I'm just going to discuss with you. So which formula are you going to use? So we have a random number of 100 pieces of wood is cut using a machine. So what is this 100 pieces? So this is our sample. So we have n equal 100. So the sample mean of length is 1.06 and the sample standard deviation is 0.08. So according to the scenario that you have over here, if I wanted to find 90% confidence interval for mean, so which formula do I have to use? Formula number 1, number 2, or number 3?
Number two, because n more than 30.
Exactly. So you're going to use formula number 2. So why is it number 2? Because I cannot use formula number 1 because sigma is not given in the question. Remember, we can only use formula number 1 if the value of sigma is given. But no value of sigma is given in the question, so you cannot use sigma. And why do you use formula number 2? Because we have n equal 100. And remember, when your n is greater than or equal to t, so that is going to be considered as a big sample size. So you are going to use formula number 2. So that is going to be for the case of number 2. And for the case of number 1, it's already been discussed in the question, so I'm not going to mention it. But I might as well address it for this case as well. Number 1. So it says over here, the mass of vitamin E in a capsule manufactured by a certain drug company is normally distributed with standard deviation of 0.052. So here, it says standard deviation. But is this standard deviation of population or is this standard deviation of sample? How do we know? Can anyone tell me whether this is for sample or population?
Population?
Exactly, for population. How do you know it's for population? It doesn't mention
State on
anything.
the question.
Okay, so how do we know that this is going to be a value from population? Because if we read the first sentence, it doesn't say anything about being a sample. When there is no word sample is being said, automatically this is going to be value from a population. And when we have a standard deviation from a population, according to the symbol that we have seen before, this is actually sigma. So sigma is going to equal 0.042. And when we wanted to find 95% confidence interval for population mean and sigma is already given, automatically we have to use which formula when sigma is given?
Number 1.
Exactly. So we are going to use formula number 1. So formula number 1. So where we have to use the sigma. Okay, and what about number 3 then? So it says over here, a study on number of drills that can be made by micro drill machine is conducted. A random sample of 15 micro drill machine. So our sample is 15. Okay, so we have to find 95% confidence interval for mean. So which formula would you use for this case?
Number 2.
Are you sure about that?
Three, small.
Okay, that's right. This is going to be formula number 3. Yeah, because our sample size is small. It's less than 30. So we're going to use formula number 3. Okay, so I think basically like you have the idea now, so which formula do you have to use. So that is going to be the most important point. So my suggestion is like do a lot of exercise on this and please listen to the video as well so that you can get the idea for each of the subtopics. So this is what we're going to do every week. So I'm going to compile questions from the previous week, material from previous week, and we're going to discuss it together. So it could either be from final exam, it could also be from tests. Okay, so I think this is all from me for today. So is there any question that you would like to ask before we end the session?
Miss, I have a question.
Okay, sure.
About the previous question, the calculation.
Previous question calculation? You mean this one?
How to find the alpha? The 1 minus alpha, you get 0.9.
Okay. Right. So what is being given in the question over here? The 90% confidence interval. So this is called as the confidence level. So this is called as confidence level. Okay. So for example, if the question says find 90% confidence interval. Okay, so that is a formula for this. The formula is 1 minus alpha is going to equal our confidence level. So if our confidence level is 90%, so that is why we're going to substitute 1 minus alpha equals 0.9. Because remember, in statistic, whatever that is in percentage, you have to change it into decimal, then only you can do the calculation. And 90% is actually 0.9. So therefore, when you arrange this, I'm going to bring this to this side, bring this to the other side. So I will get alpha is equal 1 minus 0.9. So it's going to be 0.1. And if you notice in one of the question over here, so instead of 90, so it says 95% confidence interval. So what happens when you have 95% confidence interval? it will be the same idea. So 1 minus alpha is going to equal 95%. So that is going to be 0.95. So my alpha value is going to equal 1 minus 0.95. So that is going to equal 0.05. So basically, it depends on this value given over here. So that will be your confidence level. Right, so does that answer your question?
Okay, madam.
Azim?
Thank you. Yes. Thank you.
Anything else?
No.
No? Okay, so if you don't have any questions, I'll end here for today. And I'll see you guys in the next section next week. All right, see you guys then. Bye.
Thanks.
Bye.
Thank you, miss.
Thank you, madam.
Thank you, madam.
Madam.
No problem.
Thank you, yeah.
Okay,
Thank you, madam.
no problem.